Okay, so this Sunday was all about learning about syscalls because I don't know why. I did the poll video, then I looked at ePoll randomly, and then I started looking into syscalls, and so now that's what I do. Anyway, so I stumbled upon the sendfile syscall, which can be used to optimize the bit when you're sending a file, a file to some socket. And so here I have a little example where I have a TCP server and just a very simple while loop. I accept a client. As soon as he connects, I already opened the file above, and as soon as he connects, I just read from the file and send it to the client. And I just do that in a loop as long as there is data in the file. And when the file is closed, I close the connection to the client, and I also reset the seek head on the file. And so if I run this, we can see that that works. I just have a I basically have a netcat here, and it just receives this 100 megabyte file that I generated. So this is the 100 megabyte one, and it takes about 100 milliseconds and something. And so you can do this. What sendfile does is that instead of reading and sending like this, which makes it so that data needs to be copied from the kernel to user space, and then when you read, data is from the kernel to user space, and when you send some data from user space to the kernel, and then the kernel sends it. So there is this, the user space is this middleman in this case, when it's not necessary because you're just copying, it's just the same buffer that you're receiving and sending. So you can replace all that by this very simple loop. So we will still have our send size like so, and we will still have our little do while send size is greater than 0, so while there is still data. And you can do send size is equal to send file. Yes. The first argument is where it's going to be sent, so that's the client file descriptor. Then the nfd is just fd, which is the file descriptor of my file. Then the offset can be null. You can use it to keep track of the offset, but we just reset it every time, so that's not necessary. And then that's the number of bytes that will be sent. So in our case, to make the comparison fair, we can keep the same buffer size, like so. And so you will see that if I run this, the time it takes on each iteration doesn't change at all, which surprised me. And then I digged a bit into it, and it turns out that sendfile is like the copying of this buffer is not the bottleneck in this case. In this case, the bottleneck is just networking, even though it's localhost. And so what this will save in this case, sendfile, well, in all cases, is just CPU cycles to copy from and to user space and to the kernel. So I have a little demonstration with that. Oh, that's Cloud Code, which helped me do this little benchmark. And so if I do PID stats, I think, and then P, and then I will put the PID of my executable. So if I restart this, so this is the send. Maybe let's start with the classical read and send, like this, and I print the buffer. Let's copy this PID. I print the PID is what I meant. And so now I can do PID stat, which basically gives me the CPU usage of this process at every second. And now if I run my little test, we can see that the CPU usage is around 16, 17%, 18 sometimes. And so yeah, let's let it finish. And yeah, it was about 17%. So now if I put it back to sendfile, and I restart it, I redo the whole PID thing, like so. Yes. And now we should see that when I run the same command as before, the delay is still the same, but now the CPU usage has dropped to 7% and 6%, which is kind of awesome. We just saved half of the CPU usage we were using just by replacing this little loop. So I can see how if I would have a server with a lot of clients sending a lot of files, maybe, I don't know, videos, and you pre-transcoded the video and you have them cached on some servers or whatever, and so you have these files already prepared on the file system, and you would want to send them to a lot of clients. At some point, I can imagine if you have like a immense amount of networking, that the CPU would become the bottleneck, and so this syscall could be kind of cool. Anyway, that's all I've got, and I hope you enjoyed it. If you enjoy those little syscall videos, I think I'll make a bit more because it's quite interesting. So anyway, that's it for this one. See ya.